In this video, we're going to take a look at section 8.2, problem number 6, which has to do with the sampling distribution of a proportion. So according to a study conducted by a statistical organization, the proportion of people who are satisfied with the way things are going in their lives is 0.88. Suppose that a random sample of 100 people is obtained. Complete parts A through E below. So the 0.88 is the population proportion, and then we're going to look at samples of 100 people. So suppose the random sample of 100 people is asked that question. Is the response to this question qualitative or quantitative? So this is review. You're either satisfied or not satisfied, which is qualitative. So the response is qualitative because responses can be classified based on the characteristic. Second question, explain why the sample proportion p hat is a random variable, and what is the source of the variability? So depending on what sample, if you take different samples of 100, you're going to get a different proportion each time. So the sample proportion is a random variable because p hat varies from sample to sample. The variability is due to the fact that different people feel differently regarding their satisfaction. So the next portion of the question asks you to find the mean and standard deviation of the sampling distribution, and also to make sure that it satisfies requirements. So if you take a look at the notes from the section, or if you look in the textbook, for a sampling distribution of p hat, this is a distribution in this case of all samples of size 100 from a population that has a proportion of 0.88. So the shape of the sampling distribution is approximately normal, provided that this requirement is met. N times p times 1 minus p is greater than or equal to 10. Also, the mean of the sampling distribution is equal to the mean of the population. The standard deviation of the sampling distribution is equal to the square root of p times 1 minus p divided by n, where p is the population proportion and n is the sample size. So getting back to our question, describe the sampling distribution of p hat, the proportion of people who are satisfied with the way things are going in their life. Be sure to verify the model requirements. So the model requirements are the sample size can be no more than 5% of the population size. That means independence. So if we have a random sample of 100 people, there are many more than 100 people that this question could be asked, so that satisfies the first requirement. The second requirement, substitute a 100 for n. P is 0.88 times 1 minus 0.88, and verify that you get 10.560. So the set requirements are satisfied. So the distribution of p hat means the mean of p hat is equal to the population proportion. So that equals 0.88. The standard deviation of p hat is equal to the square root of p times 1 minus p divided by n. So we substitute p for population proportion, which is 0.88, times 1 minus 0.88, divided by the sample size of 100. So when we round it, we get 0.032, but I want to make sure that I go a few more places than that for the next question, just to make sure I've got it to enough places. So we get the square root of 0.88 times 1 minus 0.88 in parentheses divided by 100. And we end up with approximately 0.032496. So for our purposes, we want to round to 3 places, 0.032. But for the next question, I might want that to be a few more places. So in the sample obtained in part A, what's the probability that the proportion who are satisfied with the way things are going in their life exceeds 0.92? So the sampling distribution represents the distribution of all samples of size 100. So that means it'll center around the population proportion 0.88. If I want to shade the area that I'm interested in, 0.92 is over here to the right, and I want to know what the proportion exceeds 0.92. So I'm looking for the area from 0.92 to the left. So if we're looking for area on a normal distribution, for the calculator we use normal CDF. A reminder, we use the interval. The lower interval is 0.92. The upper part of our interval, this goes from 0.92 to infinity. We have a mean of 0.88 and a standard deviation of I'm going to put in more decimal places, 0.032496, and I'll show you why in a second. So when we put this in the calculator, we go to our distributions, normal CDF. Lower is 0.92, upper is infinity, a mean of 0.88, and a standard deviation of 0.032496. Paste, and what we end up with is 0.1092, which matches the value here. So if you would have put it rounded to 3 places, let's just see what would happen there. So instead of putting 0.032, if I just put 0.032 rounded to 3 places like I did in the other problem, notice I get a different answer, 0.1056. So even though the question above asks you to round to a certain number of places, the more places you round to, especially if we're rounding to 4 places for our answer, the more precise your answer will be. All right, last question. Using the distribution from Part C, would it be unusual for a survey of 100 people to reveal that 81 or fewer people in the sample are satisfied with their lives? So we find the probability that goes with 81 or fewer people. So we're using the same distribution above, except now for Part E, I'm going to do 81 or fewer. So I need to find what proportion that is. So P hat, 81 or fewer, 81 over 100, is 0.81. So I'm trying to find the area that goes with 0.81 or fewer. So we use normal CDF. This time we're going from negative infinity on our interval to 0.81 with a mean of 0.88 and a standard deviation of 0.032496. We put that in our calculator. Normal CDF. This time I'm going from negative infinity to 0.81. Same mean, same standard deviation. Oops, I better make it a little few more decimal places. So 0.032496. We end up with 0.0156, which notice is our answer. And anything unusual, if it's not given as a probability, if it's less than 5%, it's unusual. So the probability that 81 or fewer people in this sample are satisfied is about 1.56%, which is unusual because it's less than 5%.